All right, we're going to take a look at number 13 in this video. So getting a little bit bigger numbers here. So one thing I definitely when I see this, I want to check for a GCF. So in this case, I know that they're all divisible by 5. So I'm going to take out a 5, which will leave me with 9r squared minus 24rs plus 16s squared. Okay. Just getting into the idea of this being, I know that my first term here and my second term, or my last term, are both perfect squares. So that's kind of when I'm starting to think, could this be a bin squared problem? And kind of to check that, I'm going to kind of break apart this into its roots. So 3r times 3r, and this would be 4s times 4s. And if this is a bin squared problem, then the center one should be 2 times 3r times 4s, which in this case, 2 times, yep, that would work. Okay, so that means this is a bin squared problem. Okay, so if I break it apart, I'm going to be using the a and the b. Okay, so it'll be, since there's a minus sign, it'll be 3r minus 4s squared. Okay, now again, sometimes it's hard to see that right away. So if you had just gotten to this point here, you could still do a factor box as well, right? So it's like not like you have to use this trick every time. If you don't see it and it's not convenient to you, you can use a factor box. Okay, and you should get the same answer. So nothing to worry about there. So if I make my factor box, okay, same idea. Well, I already kind of know the factors because we just did it here, but I know it's going to be 3r and 3r and negative 4s and negative 4x, and that'll give us negative 12rs and negative 12rs, and that should work. Okay, so again, if bin squared is something that you don't see naturally, obviously you want to get better at that, but for now you can still use a factor box and it will work just fine.